Today we're going to learn about absolute value expressions. The problems that you're going to be focusing on today come from the book section 2.2, Subtracting Rational Numbers. But our I can statement is I can simplify expressions using absolute value. So our note today, just to kind of remind you of a couple of things before we get started, our note is to remember to follow order of operations, or the idea of order of operations. Absolute value bars are really a grouping symbol. So the way that you're going to approach the problem is exactly like you would if you were looking at parentheses. The difference is that and it's kind of actually the same, when we get down and we have one number inside the parentheses, we drop the parentheses. But when we have absolute value and absolute value bars around a particular number, let's say the absolute value of 7, what we're really answering is the distance from 0 on a number line. So the absolute value of 7 is 7, and the absolute value of negative 7 is 7. So when we're talking about one number and absolute value, the absolute value is always positive. Simplify each expression. Show work. Let's look at number 1 together. Negative 5 plus the absolute value of 7 plus 5. So our attention should immediately go to the absolute value of 7 plus 5. So if I was treating that like I would if it was parentheses, we would just add the 7 plus 5 together, which we know is 12. But in this case, we need to leave the absolute value bars because we haven't yet answered what is the absolute value of 12. As far as the rest of the problem, we're just going to bring down negative 5 and the plus sign. Now we have negative 5 plus the absolute value of 12. And I want you to think of this as really all you're doing is combining constants or like terms. So if I'm combining a 12 and a negative 5, then I have the answer of 7. Notice that I do put in a circle or a box or something to signify that that is my final answer. Moving on to number 2, the absolute value of negative 3 plus 5, that's going to give me a positive 2. And notice that I still have the absolute value bars because I haven't yet answered the question of absolute value because we just now got it to the point of one number. As far as the rest, we have a plus and negative. Well, plus and negative really just means to subtract a 6. Absolute value of 2 is 2, and 2 minus 6 gives us a negative 4. So if you're saying to yourself right now, Ms. McDaniel, I thought you said that absolute value has to be positive. Well, we're talking about the absolute value of one number. You can clearly see that when I get to this step 2 minus 6, we're no longer talking about absolute value. We're just talking about what is 2 minus 6. So yes, it is entirely okay to have an absolute or an answer to any of these problems that is a negative. I want you to look at number 3 and number 4 kind of together, and you'll notice that the problem is the same in terms of the number. I'm using a 12, I'm using a multiplication symbol, and I'm using a negative 5. The difference is that they're laid out a little differently. Number 3 is the absolute value of 12 times negative 5. Number 4 is the absolute value of 12 times the absolute value of negative 5. So the way you treat it is going to be a little different. 12 times a negative 5 gives me a negative 60. And then the absolute value of negative 60 is positive 60. Final answer. Something else I want you to notice is the way that I'm working the problems. You'll notice that I am working down the page. You will always work your problems going down the page instead of going across. And it kind of just makes sense because what you're doing is breaking down one step at a time until you have a final answer. On number 4, instead of looking at the quantity together of 12 times a negative 5, we have to take the absolute value of individual numbers. So the absolute value of 12 is 12. The absolute value of negative 5 is positive 5. And then we just bring down the multiplication symbol. So now we just have 12 times 5, or 60. And so if I was looking at this problem on your work and you were saying, okay, Miss McDaniel, it's the same answer. You're right, it is the same answer, but you can see that the process is very different. And so if you were to show your work incorrectly, then you would not be able to receive full credit. So not only is a 60 important, but also the step in between. Now we're going to still be working absolute value, but we have a little substitution. So you can see right away, we can see the value of A is -4, B is -8, C is 2, and D is 0. So the first thing we're going to do is just use that basic substitution. For our value of B, once again, that's a -8, and we have a D, I'm just going to bring down my negative and then substitute in the B, which is -8. Plus D, which is 0. We like 0. Zeros are easy to work with. And my attention should still be within our grouping symbol. In this case, we know that our grouping symbol is the absolute value bar. So -8 plus 0 is -8. Notice that I keep the absolute value. You can't drop the absolute value until you get it down to one number. So that's exactly where we are right now. The absolute value of -8 is 8, and then you just bring the negative down. So our final answer is -8. Make sure you do the substitution part first. Let's look at our number 2. Number 2 is the absolute value of 7a, or 7 times, absolute value of 7 times a, divided by kind of messed up, so I'm going to just kind of fix that here. That is just supposed to be a division symbol. And then divided by the absolute value of -b over c, or divided by c. So lots of division going on here. So let's first identify our a. A is -4, and C is 2. We already know B is -8. 7 times A, and we know our value of A is -4. So I'm just going to put that in parentheses to remind myself to include the negative, and then I'm just going to bring down the division symbol. And then I'm going to make big absolute value bars because I am a little uncomfortable with the diagonal division sign. I'd rather see a horizontal. So we know it's a -b. Well, the value of b is -8, so that's a -8. Once again, the value of b is -8, so when we substitute in b, we're talking -8, but there's already a negative there, so we need to keep both of them. And then divided by c, or 2. So to simplify, within our first absolute value, we have 7 times -4, or -28. I'm going to leave the absolute value bars, bring down the division symbol, and then we have a -8. Well, I know that a negative is a +8. Notice that I'm just doing this one step at a time, and that it's perfectly okay to simplify within each grouping symbol at the same time, because we know that what I'm doing in this absolute value has nothing to do with what I'm doing in that absolute value. And that grouping symbol has to, whatever's inside of the absolute value has to be done first. So now we have the absolute value of -28, which is 28, divided by the absolute value of 8 divided by 2. Well, I know 8 divided by 2 is much better known as 4. Very important to still keep my bars there because I just now got it down to one number. Last step, 28 divided by 4, or final answer of 7. So my advice on this type of problem is really just to kind of take your time and substitute in, use parentheses, especially when we're talking about a negative, or just including the negative within the variable, or substituting the value within the variable. Parentheses help us to stay organized. Last but not least, let's look at number 3. So now we have B plus C. We've already seen the value of B, and we've already seen the value of C. So we have -8 plus 2. and then that quantity all over 3. Negative 8 plus 2 gives me a negative 6. Keep your bars. The success of doing an absolute value problem is to know when it's time to drop the bars. And now I just got it to that point. The absolute value of negative 6 is 6. And then I can go ahead and divide by 3. Final answer, 2. We want to make sure that we only use the absolute value bars around the numbers that it's actually around. We don't want to include that around the entire problem, just what you see. So that is going to do it today for simplifying absolute value expressions.